Dear students, welcome to our science episodes. Today we are going to discuss properties of sound waves. Today we are going to discuss together the second property of sound waves, sound intensity. It's a property by which ears can distinguish strong and weak sounds, and it is measured in decibel. Sound intensity is the amount of energy carried by the sound waves that fall perpendicular to a unit area surrounding this point in 1 second. Due to the wide range of sound intensity and the variable sensitivity of human ears to different sounds, scientists agreed to represent sound intensities and noise by what is called decibel scale. So in this scale, you can find the decibels units here and the source of noise or the source of sound on the x-axis. Starting from the moderate sound level or the green area and then going to the very loud sound, extremely loud, and you can see that the dangerous zone is above 80 decibel. Now, factors affecting sound intensity. Sound intensity could be affected by distance between the sound source and the ears. You can stand in front of your friend who is making a sound and then move away gradually from your friend. You will notice that the sound intensity decreases gradually as the distance between both of you increases. The inverse square law. It states that the sound intensity at a point is inversely proportional to the square distance between the source of the sound and that point. So if we want to measure the sound intensity at point 1, it is inversely proportional to square of the distance between the sound source and that point. And it is represented by this graph. You can find the relation between the sound intensity and the distance inverse proportional. Well, can you explain to me or give reason why students prefer to sit down at the front rows, not at the back? This is because at the front rows, the sound is more intense. This is because the distance between you and the source of the sound decreases. What will happen if the distance between the source of the sound and the ears is doubled? Then the sound intensity will decrease to 1/4 of the original sound intensity. Now, what will happen if the distance between the source of the sound and the ears is increased 3 times? The sound intensity will decrease to 1/9 of the original sound intensity. What will happen if the distance between the source of the sound and the ears is decreased to the half? The sound intensity will increase 4 times the original sound intensity. Other factors affecting sound intensity. The amplitude of the sound wave. Now, look at this picture. Try to fix one end of a ruler on the edge of a table. Pull up or push down the other free end of the ruler and then let it go. You will find that the amplitude of the vibrating ruler decreases by time, and accordingly, the sound intensity becomes weaker. Look at these two pictures. Higher amplitude and more sound intensity. Lower amplitude and lower sound intensity. then we can conclude that sound intensity is directly proportional to the square of the amplitude. Now give reason why does sound intensity of the vibrating rule decrease with time? This is because the amplitude of the sound waves decreases by time, and sound intensity is directly proportional to the amplitude. What will happen if the amplitude of the sound wave is doubled? You will find that the sound intensity will increase 4 times. And what will happen if the amplitude of the sound wave decreases to the half? Then the sound intensity will decrease to 1/4 of its value. Here is the relation between the sound intensity and the amplitude, and it's obvious that it is direct proportional relationship. Now give reason why is the sound intensity lower in air than in carbon dioxide gas? Try to guess. This is because the density of air is lower than that of carbon dioxide gas, and sound intensity decreases with the decrease of the density of the medium where it travels. So, wherever the density is lower, then the sound intensity decreases. The other factor affecting sound intensity is the wind direction. Sound increases if it travels in the same direction as the direction of the wind. And of course, the opposite is correct. It decreases if it travels in the opposite direction as the direction of the wind. Now, let's talk about the area of the vibrating surface and how it affects sound intensity. Make a call to a cell phone adjusted to the vibration mode. The phone is carried on the hand of your classmate. And ask your partner to put the phone on an empty box, opened at one of its sides, to act as a resonance box. Compare the sound intensity in both cases. Of course, you will find that the resonance box increases the area of the vibrating surface with the air inside. Therefore, sound intensity increases when the source of sound touches a resonance body, like the box, due to the increase of the surface area of the vibrating body. This means that you can hear the tone of the vibration when the cell phone is put in this box rather than holding it in the hand. Now, what is about the vibration or the tone of vibration of a cell phone? Is it more intense when put on the table or held on your hand? Of course, the sound intensity increases with the increasing vibrating surface. So, the sound is more intense, or you can hear the tone of the vibration more intense when the cell phone is put on the desk surface and not in your hand. What is the scientific concept behind fixing the strings on a wooden box in musical instruments? This is to increase the sound intensity by increasing the surface of the vibrating area. The fifth factor affecting sound intensity is the medium density. Take a look at this picture and let us discuss this activity together. To do this activity, you need an air vacuum pump. This is an air vacuum pump, a glass jar, a sound source like this alarm clock. Put the alarm clock in the air vacuum pump and cover it by the glass jar. Evacuate the air inside the jar partially by drawing the arm of the vacuum pump outwards. Compare the sound intensity before and after evacuation of air. You will find that air density decreases as you pull the air vacuum pump outwards, and the sound intensity decreases too. Sound intensity will increase as the density of the medium through which sound travels increases. Now it's time for questions. Write the scientific term. It states that sound intensity is inversely proportional to the square of the distance between the source of the sound and that point. This is called the inverse square law. Sound intensity and noise level are measured in decibel. If the sound intensity is greater in air than in hydrogen, which gas is more dense? Of course, air is more dense than hydrogen because sound intensity increases with the increase of the density of the medium. What will happen if the distance between the sound and its source is doubled? The sound intensity will decrease to 1/4 of its value. Thank you. Dear students, thank you for watching and see you later in other science episodes.